Yeah.
Yeah. Can we go over the divide by 4 thing?
Oh yeah. So real quick, for those of you who missed last time, it was a really bad class to miss. We talked about this. And just in case it helps anybody out, I love this idea, because this really is what the idea is. This is why it is not imaginary. It's a real thing. If I multiply by a full -1, I go all the way there. So if I multiply by half of a -1, I go here. It's that halfway point. And if you get further in math, we could stop here, or here, or here, or here, or here. Right now, let's talk about the major stopping points, right? So this kind of helps you remember, so it's 1i, -1, -i, 1i, -1, -i, 1i, -i, 1i. That was kind of neat. I like that. Math inherently has a beat. So I to the 0 is 1, I to the first is I squared is?
1.
No,
-1.
-1. And then I cubed is -i. See, 1, I, -1, -i. And then I to the 4 starts over again. It's like a quarter turn. So of course if you take 4 quarter turns, you end up where you freaking started. Damn. Uh-oh. So if you missed last time, that sucks. So that means that something like I to the 12th is easy.
1.
Why is that 1? Because it's 3 full turns, right? So 4 goes in evenly. What's the remainder? 4 goes into 12 3 times, with the remainder 0. That's a way to do it. So what's I to the 17th? Well, 4 goes into 17 with remainder 1. So the remainder tells you where you really are. If I turn around 7 times fully, I'm going to end up facing the same way I am. So it's like this divided by 4 step goes in this many times with remainder. The first step is like getting rid of all those turns. All right, you turned 4 times. Stop. And then you had 1 quarter turn after that. So that's why it ends up being I. So what about I to the 87th? 4 goes into 87. Yeah, 20. So you could do this for yourself. 4 goes into 84, right? And then how much extra? 3. So this is, what's I to the 84th power? 4 goes into it, so what's I to the 84th power? 1. Every fourth one, it's 1 again. Why? Because it comes every fourth. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, up to 84. So it's going to be 1 again. So that's why it's always equal to I to the remainder after you divide by 4. When you divide by 4, you're dividing out all those complete terms, right? And what's I cubed? This is what you have to memorize right here. So if you memorize this, you just have to look at the remainder. It'll tell you where you are. So I cubed is -I. So that's what this would be. If I turn around, if I do 87 quarter turns, well, that's 21 full turns, and then 3 quarter turns. So that's why I end up at I cubed. I end up at -I. Okay, maybe. There's another way to do this. I'll show you. So, I to the 18th. Isn't that I squared to the 9th? So if it's even, you can always do this. And what's I squared? And if I have an odd number of -1s, it comes out to be -1. Yes, that's another way to do that. Or you can just say 4 goes into 18 with 2 left over. I squared is -1. There's the answer. So if you had I to the odd power, this would be I squared to the 12th times an extra I. Oh shit. So this method tries to base everything on I squared, which is the most important I value, the I squared one. Is that cool? Do you see that's 24 I's? Do you see that? It's 24 I's, but I have 25, so there's an extra I. I squared is -1. What's -1 to the 12th? -1 to the 12th. If you have an even number of negatives, they all kill each other. So it ends up 1, so the answer to that is I. Or 4 goes into 25 with 1 remaining, so this equals I to the first, which is I. You see why I teach it the first way first? Because it's a much more direct route. And these are the things you need to know. But there's another way that bases it off of squares if you want to do it that way instead. It's up to you. Pick one. Don't just go, it's too many choices. I don't know what to do. Don't do anything. That's bad. Okay, all right. Anything else from homework stuff? Yes?
10.7, number 21.
Did I make, wait, 10.7, did we?
That's extra credit.
That was extra, but that's all right, that's all right. Real quick, 21. Oh, I see. So here's the way the picture would look. 800 feet along the street, and riders drop 60 feet. And they're asking how long the zip line is. So there's your right angle. Yeah. Okay. So that 10.7 had Pythagorean theorem as a part of it. I think I talked about that really quick, but the rest of that was extra.
I already see what I did wrong. I set it up wrong.
Oh yeah, you probably put the, yeah.
Yeah.
I don't blame you. Okay. By the way, guys, I mean, this has a very similar, this one has an easier cycle. If it's an odd power, it's negative. If it's an even power, it's positive. I just has two things that are in the middle. I is a quarter turn, whereas -1 is a half turn. That's why this has only 2 possible options, whereas I has 4. Because it's quarter turns versus half turns. Okay, I'll leave it alone. Okay. Okay, anything else from homework stuff? Okay, so last time, let's review what we did last time real quick. We did completing the square. Let me make sure, yeah. So what are the steps with completing the square?
-12 divided 2.
Yeah. First thing you do is divide -12 by 2.
Yeah. -6.
And that tells you what?
The thing we put in parentheses.
Yeah, this is going to eventually factor to be x, this, -6 in this case, squared. So it's really where the first step I do actually tells me what this will factor to be, and then I figure out what I put here to make that work. Now you can see what it's got to be, can't you?
Yeah.
If you FOIL this out, you get 36 at the end. But see how that's exactly -6 squared? That's the second step. That's what has to go here. And here. So I'm adding something to this part so that overall this factors like this. That's why we call it complete the square. Give it what it's missing so it can become something squared. Now why is that good? What can I do now? How do I?
Oh, radical.
Yes, square root. The minute I do this,
The exponent cancels. The plus or minus.
Plus minus.
thank you. All right, I was going to stand there for as long as it's the whole rest of the period. He's just, what the hell is he doing? Is he all right? Plus or minus because you got 2 answers. Something squared equals number has 2 possibilities, positive and the negative. And then the last step here is, why is x not by itself?
Oh, you got. I I see. So you
Add 6.
Add 6.
Man, you guys are just gonna be like, let's see if we can make them stand there just doing a little. So really, it's kind of like we notice that these are relatively easy to solve if it's something squared equals a number. So if it isn't that, we develop a process to make it that. That's that whole idea. That's what math does. Man, it would be easy if it looked like this. Well, can I make it look like this? Oh yeah, I can make it look like this. Oh sweet, then do that shit, right? Maybe. Let's do another one. So say that was A. Here's B. So my 2 steps. First step is?
Cut the middle term in half.
Yeah, cut the middle term in half. That's what's got to be in here. Notice it's positive 8, that's why it's plus 4. This was negative 12, that's why it's minus 6. You can see that? It's really nice if you let it be. And then the second step, take what I got and square it. Why does that step make sense? Because if there's a frickin' 4 there, and I FOIL this out, I'm going to get a 16 at the end. Do I have a 16 there? Shit, so I better add 16, add 16. Now this does factor to be this. So it's the checks and balances. What do I need so that this becomes something that goes like this? So I need 16 here, so it becomes that plus 4 in there. Sweet. And on this side I get 11. And now I do the same exact thing that we do over there. We take a break.
You take the square
Square root.
and plus or minus.
Plus or minus. And then last step, subtract 4. We just kind of force it in front of this dude. We like that plus or minus to be in the middle so it doesn't get lost or something. Poor little dude. Okay, and again, in case you missed it or in case you need to hear it again, the reason this process works is because if I have x minus 5 squared, if I do this, it becomes x squared minus 5x minus twice 5 plus 5 squared. Right? So what are the 2 steps in the complete square? Cut this in half, because it's always going to be double this guy, isn't it? Because it's going to have one of them and then another one of them. So that's why the first step is cut this guy in half. That's what goes here. Square this. That's what has to be there. That's completing the square. Why does it work? Because it does. It's what it does. It's what happens. Maybe. So let's do one really ugly one, and then we'll do the ultimate ugly one. Alright, so what I have to do here, oh man, I made this gross. I love it. What I have to do first for completing the square to work? There's a big difference here in the ones I was doing. The ones I was doing had a 1 here.
X squared.
I have to divide by 8. I don't have a choice. I don't care if 8 doesn't go in, it's just I have to. X squared minus, what is this going to become?
-7.
Yeah, you reduce it, divide by 2. You can't just make the 8 go away. Equals. I'll just do that. 2 steps, don't care. 2 steps are the same. What's the first step? Yeah, let me write that. Take -7/4 and cut it in half. half of something is that thing divided by, so 1/2. So if I have a fractional thing, I'm going to write this divided by 2, I'm going to write it as times 1/2, because then the fractions will play together well. So when I say divided by 2, it's the same thing as times 1/2. And now that looks a lot better. And that would be just -7/8. Is that cool? And then the second step, what do I do with that? Square. What do you get? 7 squared is 49. 8 squared is 64. Cool. So, what goes here?
-7.
No.
Oh.
This guy goes here. It's really kind of funky. The first step I do is the next step in the problem. So I don't have to. Do you want to factor this? I don't want to, but I don't have to. It's already factored. How do I factor it? X minus 7/8. I really want you to pay attention to that. I can make this disgusting as all shit. Okay, cut that in half. That's what it's going to factor like. It's part of the process. It's like, here you go. It's factored for you. Oh, man, thanks. Because that's gross. And now I added 49/64 to this side. I better add it to this side, right? Kind of good. I almost forgot, because that's a big thing you can forget to do real easy. So you got to make sure you keep these equations balanced. What do I have to do on that side?
Multiply by 4.
Yes, I need the least common denominator. What else you need? Oh, shit.
16.
Yeah, I got to multiply by 16. Oh, yeah. 16 times 11. 16 times 10 is 160. But I don't want 10 16s. I want 11. So 160 plus another 16, 176. Cool. So I get 176 plus 49 out of 64. Oh, red pen, you're so strong. 176 plus 49 is something. I guess 225.
225.
Yeah. And then what do I do? Square root?
Yes.
Plus or minus? I like it. That has to become second nature. It's got to feel wrong if you forget that. Square root of 64 is 8. Square root of 225, is that 15? Does that work? 15 times 15. Yeah, 225, yeah. That's so neat. All right, so I made one that actually factors. I didn't mean to. Oh. Now, do you notice that came out nice, which kind of sucks. Because when I add this over, I actually have to get the two answers. I can't just stop. The other ones I stop because there's a square root. There's no like terms. Here I'm going to have like terms, right? I could do 7/8 plus 15/8. So what are my two answers? What's 7/8 plus 15/8? 22/8 or 11/4. And what's 7/8 minus 15/8? -8/8, -1. That's neat. All right. When completing the square comes out to relatively nice numbers, no radicals here, right? That means the original problem was actually factorable, which hardly ever happens when I just make shit up out of nowhere. But it did this time. Okay, I like it. This idea of completing the square, this is not the only place it's used. It's something that's used in a lot of different places. So we're going to develop a shortcut for completing the square. That doesn't mean that completing the square is unnecessary. It's only a shortcut for solving this kind of an equation. Completing the square does more than that. So we're going to make a problem that's even uglier than this somehow. The only way to make a problem uglier than this is to have no numbers in it. All right, has everybody got what they want here? So here's what I mean. This is what I promised you guys last time. So for these problems, what can I really change? I mean, I had a problem, x squared minus 10x equals whatever, and blah, blah, blah. What I can change is these coefficients, right? I just make different numbers there. The process doesn't change. I can just make all those different. Does that make sense? Like I put an 8 here for that problem and blah, 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 right? I can change those numbers. So to develop a shortcut, I don't put numbers there. I just put letters. Now, if you don't want to write this, you don't have to. I think all of this is in the book. You just sit back and watch, because you're never going to have to do what I'm about to do on your own. We're going to derive the quadratic formula, which sounds like, oh yeah, thank you. But let go of the fact that there's A's and B's. Who gives a shit? What's wrong here? Why can't I start doing completing the square? What's not correct that I can do something about? The A, stupid A shouldn't be there, so how do I get rid of it? Divide by A. One other thing is, that should really be over there, right? Got to make room. So let me divide by A, and then I'll also become letters. And then I'll subtract the C over A over there. 0 over A is still 0. I haven't done anything too amazing. I just divide it by A and then move this shit out the way. Make some room. Now here's where I know you guys don't believe me when I say nothing changes. What's the next thing? What's the steps? Now I got a 1 here. I got room. What do I do? What do I do in the middle?
Take half of it.
Take half of it. And how did I say to write it when it's already a fraction?
Multiply by 1.
Times 1/2. And what's B over A times 1/2?
1B or 2A.
2A. Right? You guys have already given up. Damn it. Come on. Come on. And then what do I do with that? Second step.
Square.
Square. What's B over 2A squared? It's if you know quadratic formula, this should already be looking familiar. A little bit. Okay, we'll just find out. So now what do I do with this? That's what gets added to both sides. You see this? Well, you'll see it. And now, what does this part tell me?
X plus B over.
Yes, it tells me how this factors. You definitely don't want to be factoring this shit. And thank God part of the process tells me how it factors. And just like we did in the problem we just did, what do I have to do on this side? I need... No. So what's this guy need? 4 and an A, 11. See, I mean, this is, I really want you to realize, is this nice looking? No, there's no freaking letters, numbers. But, I mean, do I do anything different? No, I do all the same shit. For the same reasons. So I'll multiply this by 4A. So then I get B squared minus 4AC, putting it in alphabetical order. Go away. All over 4A squared. Does that sound familiar to some of you guys? Mm-hmm. B squared minus 4AC. And then what do I do? Square root. Let me see. Square root. Square root. Thank you. So then that cancels. I get x plus b over 2a equals plus or minus. What's the square root of 4a squared? And then the top I can't really do shit with. And now the last step is just to subtract that over. And since they have LCD already, see that? I just put negative b plus or minus square root of b squared minus 4ac all over 2a, which is exactly the freaking quadratic formula. I like it. So if you're given something that looks like ax squared plus bx plus c equals 0, what's one way you can use to solve it? Well, if you can't factor it, you can use quadratic. You just plug this shit in the right place. You don't do this every damn time. we did this once with no numbers. So I never had to do this again. I could just start with where I ended up. So, for example, so already got what they want from this. You didn't have to write this down. I think it's all in the book also. Par exemple. You got, say I got, what you got, Jeff? 4x squared minus 3x plus 7 equals 0. So what's A? What's B? Negative 3. What's C? 7. So what's the answers? Negative B, negative 3 is 3. Give or take, plus or minus, square root of B squared. What's negative 3 squared? 9. Minus 4 times A times C. All over twice A. That's the power of working with something with no numbers in it. Is you get a result that's true no matter what the hell these numbers are. So then you just plug it in on that step. And now we got to do a little bit of work, right? Cool, 14. So what do I get? X equals 3, give or take, square root of 9 minus, oh, what is that?
114?
Thank you.
I have no idea.
No, it's not 114. What is that? Who is it? 99. What has happened? 9 minus 16 times 7 is 112.
I was close.
Close. I like it. But this ain't horseshoes or hand grenades. Close only works in horseshoes and grenades.
Why is there 4 after the, like, why is negative 4 times 4?
Minus 4AC.
Oh, okay.
4AC.
Okay.
Cool. I like it. See, so this isn't shit we just said, well, sure, let's put an A here. No, it's we did the process to the most general statement. So once I knew what A, B, and C was, I could just plug it into the answer. Now what's really funny is some problems completing the squares quicker. Because look at all the shit I got to do still. There's actually a decent amount of shit I got to do here, right? What's 9 minus 112? What's 112 minus 9?
3.
103, so it'll be negative 103. You guys make me scared. Can't do shit with 103, but what's the square root of negative 1? Square root of negative 1. I. So I can write this as 3, give or take, I rad 103 over 8. Very gross answer, but I'm done. Which means if I graphed this dude, it would not hit the x-axis. The only x-intercepts this guy has are complex. You need that dude from the video to pick our graph up and see all the colorful shit, right? The stuff we don't normally graph. Maybe. Okay. So here, let's go into the green book. Instead of me sitting up here making all these equations up. Here we go. Page 207. Cue number 1.
So pretty much like completing the square and the quadratic formula, there's two different ways of solving.
Quadratic formula is a shortcut to completing the square. So they both do the same thing. It's just that quadratic formula, I kind of start a little into it. You know? And like I said, there's actually some problems that completing square will be quicker just because the numbers are nice. Because this, I set it up and then I still have shit to simplify, right? So believe it or not, this quadratic formula is not always the best. Especially when you can factor the situation. factor if you can.
Hope to God you guys did this first. It's got to be in that form. It's got to be in this form before you can identify what A, B, and C are.
Could you have subtracted 3x squared?
Yeah, and then your A could be negative. I just always go right towards making A positive, because in general it's a better way to go. But it doesn't matter for a quadratic formula. All right, let's take a look. What's A? 3. What's B? Negative 7. What's C? 2. So then I just throw it in this thing. Negative B, 7, give or take, B squared minus 4AC all over twice A. The biggest mistake I see here is people do this and they get negative 49, which is neat. I'm squaring a real number. It's got to come out positive, right? So I'll get 7, give or take, square root of 49 minus 24 all over 6. 7, give or take, square root of, what's 49 minus 24? Interesting. What is square root of 25? 5. So we can go a little further than that one. This one we stop because I can't do shit with square root of 103. Right? I can't do anything with this. Won't break down into anything nice. But there, that's freaking 5. So how do I do this then? I don't stop here.
You said 2 equate, or 2.
Yeah, 2 things. What's 7 plus 5? 12. 12 over 6 is 2. Or what's 7 minus 5? 2 over 6 is, no, 1/3. Okay. Sorry. Thanks for playing. But you got to be careful where that thing is left.
Can you do it with when you subtract negative, or when you subtract 3x squared?
Okay. Let's see. Let me get some paper. So if you would have done this instead, so right here, if you would have actually subtracted that over, let's see, can you see that now? Wow, I'm zoomed way in. Let's zoom out. Yeah. So if you moved the 3x squared over and made it this, this has got to come out to be the same answer since it's the same problem. But in this case, what's A?
Negative 3, 7, and negative 2.
So then I get negative B, give or take, square root of B squared minus 4 times A times C all over twice A. Cool? So negative 7. I still get 49 minus is minus 24. So I still get 25 there. Negative 7, give or take 5 all over negative 6. And if you do it, you'll get the same answers. What's negative 7 plus 5? Negative 2. What's negative 2 over 6? I'm sorry, negative 6. Positive 1/3, which is the positive 1/3 we got there. And what is negative 7 minus 5? Right? I got negative 7 plus 5 over negative 6, or negative 7 minus 5 over negative 6. Negative 7 minus 5 is
12.
negative 12 over negative 6 is 2. Still the same two answers we got earlier. 2 and 1/3. Okay. So it doesn't matter where you put it. The negatives eventually cancel if you go the other way. Yeah. What do I have to do with number 3? Yes, I got to get it in the right form. So I got to distribute. And then what do I have to do? Is everything where it's supposed to be? Who's in the wrong place? No. Subtract 1. So the one advantage that quadratic formula has is it can handle A's that aren't 1. Right, so you don't have to make this 1. So you use quadratic. So go ahead and try to finish this one out. Use quadratic formula on this. Okay. Catch up to you guys. Notice here my variable is t. Right? The only reason this is x equals negative b plus or minus because it's built off of where the variable is x. So this is going to be t equals negative b plus or minus square root of b squared minus 4 times a times c all over twice a. Is that cool? And then you just do 16 plus 8, right? The two negatives cancel. Can I do anything with the square root of 24? Yes, I can. Yeah, I can factor 4. So speaking negative 4 plus or minus 2 rad 6, because this is 4 times 6. The square root of 4 is 2. All over 4. And then I could do one of two things. I could either break this up. Negative 4 divided by 4 is negative 1. 2 over 4 is 1/2. So I can write it like that. Yes? Oh. 24 is 4 times 6, right? Okay, so then square root of 24 is square root of 4 times square root of 6. What's the square root of 4? 2. Square root of 4. Other way. Yeah. Don't have two of them, cut them in half. Yeah.
Would the 2 just be under the 6 and not the whole thing?
Where? Right here? Yeah.
Just
Negative 4 divided by 4 is negative 1. 2 over 4 is 1/2 rad 6. Yeah. Because you can break this up. Negative 4 over 4 plus or minus 2 rad 6 over 4. And then you reduce what you can. I like it. I like it. Now we did, remember this problem here? Didn't this come out complex? Right? Is that problem, is the answer complex? No, not complicated. Is the answer complex? What does complex mean? It's got a real and an imaginary part. Is there any imaginary part to this problem, to this answer? No. There's no I shit, is there? Is there an I stuff? Any I stuff? No. That's what makes it complex. This is a real answer. This is a complex answer. where do complex things come from? Why would I have an imaginary part somewhere when there's a negative inside the radical, right? So what part of this equation, this formula, tells me I'm going to have imaginary stuff? What's inside of a radical? B squared minus 4ac. So if b squared minus 4ac is negative, my answers will be complex. If b squared minus 4ac is positive, my answers will be real. What if b squared minus 4ac is 0? Somebody point out to me, why are there two answers? Why are there always two answers? What part of this tells me there's two answers? Plus or minus. So if this shit here is 0, how many answers do I get? One. I just get negative b over 2a. Right? So this guy here controls how many and what kind of answers I can expect. So this little dude right here seems to be very, very, very important. This is what we call the discriminant. Yes, it is old school. It discriminates. What's wrong with you? But it discriminates between the types of answers and the number of answers.
What happened to the two at the bottom? This where we see.
Here? So right here, I get negative 4 over 4. Is that cool?
Yes.
And then I get 2 rad 6 over 4. 2 over 4 reduces to 1 over 2. Yeah, I just reduced that. I like it. So, watch this. If they ask you, here we go. What type, oh, I love their English. What type of solutions, take the of number out. What type of solutions and how many solutions?
Where is it?
This is page 213. So again, the important thing, the main piece of the formula that tells me what type of answers and how many is b squared minus 4ac. Why does it do that? Because it is under the square root. Please let that make sense. It's under the square root, so it's the piece that if it's negative, these kind of answers happen. If it's positive, these kind of answers. If it's 0, the plus or minus goes away, you get one answer. So here, if they ask me what type and how many, I just look at b squared minus 4ac by itself. You don't do the whole damn formula. They didn't ask you what the answers are. What's b? Negative 5. What's a? 1. And what's c? 3. Negative 5 squared is 25 minus 12 is 25 minus 12, 13. That is greater than 0. It is positive. So will the answers be imaginary? No, they're going to be real. And how many answers will there be? 2. Because the plus or minus piece would still be. So there will be 2 real answers. This is like 2 real. What would have happened if there would have been 2 complex answers? This should come out to be a negative number. If the answer you get from b squared minus 4ac is negative, that means you're taking a square root of a negative number, you will get imaginary parts of answers, right? You get complex answers. So look at number 2. Try to do number 2. What type and how many? Did we not get the updated homework sheet? We got this homework here, updated dates. Take a listen to this. You got it?
Yes.
All right. Yeah. Right. So let me see here. Whoa, that's freaking me out. There we go. So what's B?
8.
So a squared minus 4ac, right? This one looks good because these two negatives are going to cancel. I almost don't care. Let me see if you guys are cool with this. The answer to this is going to be positive. You guys see that? Doesn't matter what the number is. No, not right now. If I know this is positive, what do I know? There's going to be two real answers. Done, right? Now you can figure out 64 plus 80 is 120, 144. It doesn't matter. It matters that it's greater than 0. So under the square root, it's going to be a positive number. I'm going to get real answers. What about number 3? Do number 3. And number 4. Why not? Number 4, quick little hint. What's B?
How did that become 0?
0. How did which become what? What's B? Yeah, 16 times 5. Or 4 times 5 is 20, times 4 is 80. Okay, so I'm sorry, on 4, yes, B is 0. So do these next two. If you're still not certain why we're not doing the complete quadratic formula, this didn't say to find the solutions. This just said what type and how many. That's all it said. So when they ask you what type and how many, you only have to worry about the b squared minus 4ac. That's the most important part of this equation, because it's under the radical. It's going to tell you if they're real, imaginary, or if there's only one answer. It by itself will tell you that. So on this one here, number 3, what's B? -4. What's A? 4. What's C? So I get 16 minus... What a shit! So how many?
1.
What kind is it?
Real.
Real, good, because it's not negative under the radical, it's just 0. So I will get one real answer. So again, this relates to 2 real answers means the parabola goes through the x-axis twice. 1 real answer means the parabola just touches the x-axis. See, 1 answer, right? And no answers or only complex answers means the damn thing doesn't touch it at all. It says, I'm coming, no I'm not. So what about number 4 if you haven't done that one yet? So again, this is A is 1, B is 0, because there's no x term. And C is 4. Okay, let's see. So b squared, 0 squared minus 4ac. So you definitely get 0 minus 16. You get negative 16, which is less than 0. So you get how many, what kind?
2 complex.
Beautiful. 2 complex. 2 complex. 2 complex. Yes? Where? Sorry. So it's b squared, right? B squared, b is 0, minus 4ac, right? That's right? That's b squared minus 4ac. That's that piece of the quadratic formula. So that negative 4 is a part of the thing, and then I put in a and c. Cool, cool, cool. Why is it like that? Because of all the stuff we did up here earlier. It's just that's what it is when you do the work. I like it. But you see how that's just a little side note, really. This is really kind of a side note. It is kind of important to know what kind of answers to expect. And that's the most important piece of the formula because it's in the square root. It's the part that has the most restrictions on it then. So looking at it by itself tells me a lot about what this thing can do. Okay. Now, 11.5 I made extra credit. Whoa. So I'm not going to worry about that. I want to look at 11.6 and then let us out of here. I'm pretty sure, I feel like we've done this before, but take a minute and graph this. This is page 217. Bless you. So it's x squared, bless you. Go ahead and fill in that table and then graph it. I want you to, you know the shape of this already. And then I'm going to go out of book into my own